Okay, so my page has disappeared on me. There we go. Oop. What we're going to do next is let you guys do some examples. We'll start, I will do a couple more, and then I'll let you work a couple on your own. You can pause the video in between when I present it and then when I show what the steps are, and that way you can see how well you're doing with this concept. If we have f of x equals x squared minus 6x minus 1 as our parabola, we can see right away that the a out in front of the x squared is a positive 1. So we know that that parabola is going to open up. If we're trying to find the vertex of the parabola, we know that h is negative b over 2a. And so we will find out that h, for this example, is the opposite of negative 6 over 2 times a is 1. So 6 over 2, which is 3. Again, 3 is the x-coordinate of the vertex of that parabola. It's our x-coordinate. So if I want the y-coordinate, I know all I do is plug in 3 for x, and the value that gets spit out is the y-coordinate that goes along with that x value. So 3 squared minus 6 times 3 minus 1 is going to be 9 minus 18. Excuse me, negative 9 minus 1 more is negative 10. The vertex of this parabola is going to be at positive 3, negative 10. And again, since a was positive 1, we know that that parabola is going to open up if we sketch its graph. If we're asked to put the quadratic function into standard form, or into its vertex form, maybe I'll call it, we know that looks like a times x minus h squared plus k. Okay, or you don't have to write plus a negative 10 there, you can just write minus 10 if you'd rather. But there's our vertex form if that's what we're asked for, or our standard form. Here's the vertex if that's all that they asked for. And so depending on what the instructions say, then you have different options. Now, how about there in your notes, I want you to look at f of x equals negative x squared minus 4x plus 6. I want you to figure out where the vertex of that parabola is, decide whether it opens up or down, and sketch a quick graph. Then if you would go ahead and put it in its standard form or the vertex form where we can see it, the a times x minus h squared plus k, go ahead and do that as well. Take a moment, pause the video, work on it, and then I'll show you the steps. Since a in this problem is negative 1, we know that this parabola is going to open down. If we want to figure out where the vertex is, we know the vertex is at negative b over 2a, so it'll be the opposite of negative 4 over 2 times a is negative 1. We'll get positive 4 over negative 2, which is a negative 2 for the x-coordinate of that vertex. If I want to find k, I want to find the y-coordinate that goes along with negative 2. I plug in negative 2 for x. So I have the opposite, this negative in front of the x squared stays. Negative 2 quantity squared minus 4 times negative 2 plus 6. Squaring negative 2 gets positive 4, but this negative sign from out in front gets brought down. Plus 8 plus 6, which is equal to 10. That means the vertex of this parabola is going to be at negative 2, positive 10. If we want to write it in its vertex form, where we have a times x minus h, that quantity squared plus k, then we get to write f of x equals negative 1 times x minus negative 2, quantity squared, plus 10. So more nicely, you don't have to write the 1 on there, you can just hang a negative sign out there if you'd like. That quantity turns into x plus 2 squared, and then the plus 10 at the end. Oh, wrong. There we go. I think between those two examples and the ones in part 1 of the video, hopefully that'll get you going on this. Again, if you look in the book, they'll show you a completing the square option, which I skipped over. So don't worry about that one. Unless you're interested in it, you can learn it on your own, but I won't require that part on the exam. The last little piece of section 3.1, and this is something that this author doesn't spend a lot of time on, but I'm going to point out, is that if our parabola opens up, then notice that it has a lowest point. It has a bottom, it has no top, but as far as the range goes, it does have a lowest point. We call that place, that lowest value, the minimum. If our parabola opens down instead of up, it no longer has a bottom, but it does have a top. We call that the maximum value. In either case, whether the parabola opens up or opens down, whether it has a maximum or it has a minimum, the maximum or that minimum value is the y-coordinate of the vertex. So if you know the vertex of a parabola, you know its maximum value or its minimum value, depending on which way it opens. But you also have to understand how A tells you which it is. A positive A means the parabola is going to open up, and you'll have a minimum value. If the parabola opens down, we know that by an A value being negative, and so that means it will have a maximum value and no minimum. What you cannot do is tell by looking at the number, looking at the value of K. We can have maximum values of negative 100 and minimum values of positive 1,000,000. Okay, so you can't tell just by whether the value is positive or negative. You have to look at the formula, at the equation, to decide. So if we have the function f of x equals 3 times x minus 2 squared minus 5, and it asks us, find the maximum or minimum value of the function. Okay. The first thing we have to do is find the vertex. If it's not in the form where we can pull the vertex from the formula, here the vertex is at 2, negative 5, then we have to go through the minus b over 2a and find f of that value to figure out where the vertex is. Now the maximum or minimum value is always going to happen, I'll pick a color here, it's always going to happen, or the answer is always going to be the y-coordinate. Negative 5 is the maximum or the minimum value here. Now what determines which it is the a out in front of the formula. Since a is equal to 3, and 3 is a positive number, we know that this parabola opens up. If the parabola opens up, it has a bottom but no top, which means we'll say that negative 5 is the minimum value. If we go back and look at this function that we already played with, f of x equals negative x squared minus 4x plus 6. We decided that the parabola opens down because a is a negative value. If our parabola opens down, we know that means it's going to have a top but no bottom. It'll have a maximum value but no minimum. Once we go through the steps and find the vertex, all we care about from the vertex is that y-coordinate. And that y-coordinate is going to be our maximum value. So we would say the maximum value for this function is 10. Okay. The maximum or the minimum for every problem that you do is going to be the y-coordinate of your vertex. You will say that it's a maximum value if the parabola opens down. You will say it's a minimum value if the parabola opens up. So over here on this first one, this first one on this video, since the parabola opens up, we know we're going to have a minimum value. And we know that that minimum value is going to be whatever the y-coordinate of the vertex is, which in this case is -10. Now, those are all the examples that I'm going to do. Hopefully, if you go through and play these through a time or two, then you'll get the hang of what's going on. I lost the homework assignment, so give me a second to grab a hold of that for you. And then I'll put that up on the board, and this is all that you're going to have to watch for your lecture over spring break. From section 3.1, I would like you to do problems 14 to 26 even. Now, I don't like the instructions, so instead of reading the directions and following them in this case, this is what I would like for you to do on each of the problems. You need to give the vertex of the parabola. Okay, some of them are already in the form for you, some of them you have to use the formula to figure it out. I also want you to sketch a graph. And again, sketching means put the vertex in the right place, open it up or down correctly, and that's all I'm concerned about here. Okay, you don't have to worry about how wide or how narrow it is. I would like for you also to give the minimum or maximum value for each function. Now, don't just say that it's equal to 5. Tell me that the minimum is equal to 5 or that the maximum is equal to 5. I need to see the word minimum or maximum on there along with the number, the numerical value where it is. I would also like to see the equation written in standard form if it's not already in standard form for you. Okay. That is what I am calling standard form is this one here. If you have any questions or concerns, then I would be glad to answer them in my office after spring break. And on Monday after break, we are going to go on to Chapter 4. So this will count as your lecture for this section. Thanks a lot.